Okay, let's get started. I'm going to go straight into your first clicker question today. So pipe down and whip out your clickers and turn them on. Here's the question. Shh, you're imposing a massive negative externality on people next to you, so be quiet. Imagine that you're a consultant. This is one of my favorite setups. I don't know what kind of consultant, and I can't imagine why anyone would pay you for this particular piece of consultation, but here it is. You have a client named Odysseus, who is the captain of a ship, which is to say in particular that he's responsible for steering the ship, okay? Odysseus has the following problem. He really wants to hear the sirens sing, okay? If you know Greek mythology, I'm kind of borrowing this a little bit, which is to say completely, the sirens are these beautiful women who sing in this beautiful way, and he really wants to hear them sing. Here's the trick. Anybody who hears the sirens immediately sails towards them and crashes on the rocks, okay? That's why we refer to the siren song of certain things that are compelling but lead us to our doom. For example, crack cocaine and Blendoku. What would you recommend of the following options to our client Odysseus? A, plug your sailors' ears so they won't be able to hear the sirens. B, tie yourself to the mast so you won't be able to steer towards the rocks. C, both of the above. D, forget about it. You don't stand a chance. Okay? Of those 4 possible pieces of advice, which one would you give to Odysseus? Don't say it out loud. Goodness sakes. Okay, if you need more time than this, it's bad news for Odysseus because he is heading towards the rocks as you chat. So 5, 4, 3, 2, 1. Okay, quick question. Does anybody know why attendance is dropping in this class? Is this like when everybody else is getting midterms? Yeah. Got it. Which also explains why attendance at my office hours is low. Good. Well, God be with you. And, that's just one more reason to thank you for giving you an early midterm. Let's see the answers. So, majority, just barely, 51%, said C. The good advice is to do both of these things. So to cut to the chase, can someone explain to me why they said C? No, you have a question. No, your sailors. Odysseus is the boss man. Right? Okay, now you want to say C. Yeah. Oh, come on. It's not even assigned reading. You're not supposed to. No, so tell us the story. What's the deal? And then he plugs their ears. Why? Because if they could hear the song, they would leap up and grab the steering wheel as well. Okay, so they won't steer the ship to the rocks because they can't hear the sirens. He won't steer the ship to the rocks because he's tied to the mast. Right? Is that the story? Anybody have a different explanation? This is the basic idea? Okay, next question. Oops. This is not on your handouts, because I didn't want you to look ahead. How many decision makers are involved in this scenario? Not including you. How many decision makers are involved? 0, 1, 2, 3 or more. Or no answer. Go. Okay, for those of you who have not yet sat down and gotten your clickers out, I'm interested to know, can I actually see? Yes, I can. Okay, so you've got a few more minutes to click your clicker. All right, so now come on. Have you gotten yours out? Yeah, okay, good. Okay, so we have bimodal distribution between B and B. Who said B? One decision maker. Yes. Okay, so the sailors are basically his servants or slaves or something like that. Paid lackeys. You haven't learned the principal agent model yet, right? Because it turns out that employees can do all crazy hectic stuff on their own that really will just ruin your business. But you're saying that they don't have any choice in the matter because they have to do what Ulysses says. Okay, who wants to give a 2 answer? Who said 2? Somebody. Yeah. Because you read the next page. See, now between the 2 of you guys, it's too literary. Okay, go ahead. No. Yeah, go ahead. Say.
Because every human being makes decisions with time and consistency. They plan for the long run, but also try to satisfy themselves in the short run. So Odysseus might want to hear something that makes the path now. He knows that he'll die.
Right.
So he has to have that war within himself to decide what he's going to do.
So wait, so you're saying there are 2 Odysseuses?
Yeah.
What are they? Can you distinguish them for us?
They're in his brain.
They're in his brain, but more particularly, there are different points in time. Okay, so there's the Odysseus who is talking to you, the consultant, and then there's the Odysseus who is either tied to the mast or not tied to the mast and behaves accordingly. Fine. Who said 3? Okay, so that's tricky because, so in the myth, how does he prevent them from pulling the wax out of their ears?
They really like it. Smart guy.
Interesting. Okay, but yeah, sure they could. Or, more to the point, what I had in mind was this. You've got a bunch of sailors who can decide whether or not they want to go and grab the steering wheel or jump over the side of the boat or, whatever, and just sit around playing banjo. You've got Odysseus in the future who gets to decide whether or not he wants to steer towards the rocks, right? Because the sailors could also jump up and steer towards the rocks if they didn't have the wax in their ears. Yeah, they could choose to take the wax out of their ears. We're going to forget that. Let's just say he nailed it into their ears or something. And then there's Odysseus, the sort of pre-rocks Odysseus, who's making decisions about what to do ex ante with both the sailor folks who have a potential to make some temptation-based decision and his future self who has potential to make some temptation-based decision. Okay, everybody comfortable with that? Yes, good? Okay, fine. All those answers were reasonable. And the reason I put 3 or more is because I just, I wanted, because you might have said, well, the sailors, that's a ton of decision makers, but, okay, fine. Wait, so what were the, yeah, so that was B and D. Good. All right, now let me back up. Here's the outline for today. So we're talking about sophistication and the 2-self model. And I say sophistication in particular because that's where the difference between the sort of the self that looks ahead in a sort of rational way, like you going to the next page of the handout, and the self who acts impulsively in the short term. It's for the sophisticated that those things become really interesting, but the same thing is going on with the naive. It's just a question of what the naive thinks is going to happen to him in the future, right? So it's almost as if the sophisticate knows that there are 2 Odysseus's, and the naive naively pretends that there's only one Odysseus. Okay. So we're going to talk a little bit about neuroeconomics, and then we're going to go into using game theory to model particularly the sophisticate, but you can use game theory for both the sophisticate and the naive. Okay, so we've done that. So neuroeconomics is a fun thing. It basically, there's all kinds of people in fields called neuroscience and cognitive science who are trying to understand the actual sort of physical basis of human decision making. So what parts of the brain are involved in different kind of decisions? How do decisions actually get made neurologically? What's the interaction between physiology and neuroscience? So for example, if a whole bunch of hormones get dumped into my bloodstream, how does that interact with synapses in my brain under different conditions, et cetera, et cetera. Neuroeconomics is the intersection between that and the study of economically relevant decision making. So you can see that this is very much parallel to psychology and economics. Psychologists typically take the brain itself as a black box, right? So in a process chart, you have sort of this thing leads to this thing, leads to this thing, and then there's this big black box. And who knows what happens inside the black box, but what we know is that something comes out here. Okay? So there could be all kinds of things happening in there, but this is like your income shows up, and then you spend that money on some consumption, and that consumption gives you, well, maybe I should take out a link, and then the consumption turns into utility or whatever, and out comes some behavior, right? And this is the brain. And psychologists say, we don't know what's happening in the brain. All we need to know is sort of some sort of conceptual theory of what happens between the going in and the going out. We don't need to know the brain architecture. Neuroeconomists say, actually, no, we can learn quite a lot from what's actually going on inside the brain. It can help us to confirm different ways of thinking about decision-making and different ways of intervening. So I think I have enough time to take a short tangent that I think will be illustrative. I have a colleague with whom I'm getting ready to submit a proposal for one of these things called Matrix Seminar, which is where you get money to hold a seminar and all kinds of smart people sit around and try to come up with some complicated research agenda. And this guy's idea is has to do with financial traders, right? Traders on floors where you get into this high-pressure thing and prices are going up and down, prices of stocks are going up and down, and you have to decide whether to buy or sell. And this fellow has the idea that that by and large, traders are making decisions on the basis of some deliberative cognitive process. What is actually going to make sense for me and my clients in the long term? And then under certain conditions, particularly when prices start to move rapidly, a different part of the brain gets triggered that causes what he refers to as herding behavior. He didn't make up the term, but this is his idea, is that there's herding behavior, or you could think flocking behavior. You see birds, and if you've ever seen 50 birds flying together and they're going one direction, and all of a sudden they're all going the other direction. And you're like, how did that happen? Right? Because basically they're all following, and it's tricky. You can actually model a flock of birds using computer code. It's tricky because there's not like there's one leader. In a herd of cows, there's usually one leader. In a flock of birds, everybody's just following everybody else, but they still somehow. So he has this idea that this neurological process gets triggered under certain conditions, and people see prices going up, and they just say other people are buying, I'm going to buy. Right? Or other people are selling, I'm going to sell, and so you get bubbles and crashes. And the point of that is, you could get there using just psychology and economics. But his idea is, I should be able to observe that happening in the brain, and then I can then use this weird little piece of portable equipment called an FNIRS scanner and put it on your head while you're trading, and I can then observe the part of your brain that is associated with herding behavior light up and say, whoops, time to pull the plug on the market. You guys are going crazy. Okay? So this is the kind of thing that we might think about why it would be useful to go inside the brain. Here's another reason. Okay? And this is an extremely sort of in some sense crucial or critical piece of research in behavioral economics. So the idea here is that there are two decision makers inside the actual brain. Okay? So the two different versions of Odysseus. There's one that we could refer to as the delta self. I think I'm making that up. No, I don't think I'm making that up. That makes long-run decisions based on cognitive thought. Yeah.
This one only wants to write, so the waiver just also buys whatever asset, it just literally gets the train.
So this is sort of like someone who's arbitraging something. He's pretty sure he's going to sell just before the crest and not get smashed. Are you willing to come to the seminar? I'll put you on the proposal. No, let's talk about that later. Another answer is email me and I'll send you the paper that addresses that question. There are conditions under which we think that actually can't happen. But I don't want to talk too much more about the trading. It was just an example.
For a normal human being, is there a maximum of two decision makers in your brain?
That's a dissertation. I mean, it seems unlikely that you can't think of a situation in which it would be more effective to model decision-making in terms of more than two selves. Indeed, I'm going to show you pretty soon a model of like the choice of when to go to a movie, and I'm going to say, okay, there's a different self in each time period. But they're all going to be either a delta self or a beta self. And more to the point, in any decision, there's going to be a delta kind of decision. So, for example, in the problem set thing that we did last time, right? From period one, you're dealing with a beta. Okay, let's just get this on the screen because it's obvious where we're going, right? So the delta self makes these long-run trade-offs. They're all in the future, and the beta self makes short-run decisions based on immediate reactions. Okay. So if you're in period one, you're trying to decide, should I do the problem set Friday, Saturday, Sunday? The trade-off between Saturday and Sunday is a delta decision, right? But the trade-off between Friday and either of those days is a beta decision. So these two parts of your brain, we think, are operating simultaneously. Now, what you see in a second on the next two slides from now is that actually they're both operating a lot of the time, even when you'll see. It's complicated. Okay, so we have the delta self, long-run decisions. Now, I don't mean makes decisions that have long-run consequences. The beta self deals with decisions that have long-run consequences as well, right? Sailing to the rocks and dying, that's like a permanent long-run consequence. The point is that it's long-run decisions, meaning decisions that take the long run into consideration. Okay, and we have this idea based on existing research that there are certain areas of the brain that are essentially sort of more used for cognitive processes like this. And one example that I think I don't know much about the brain, by the way, but there's this part of the brain called the lateral prefrontal cortex, which is sort of like cognitive headquarters. Beta self, short-run decisions, meaning makes decisions based on short-run considerations. Right? Whoops, rocks, turn away, and that's associated, among other things, with a complicated set of stuff in the brain called the limbic system, which is sort of associated with emotional response and so forth. So here come these folks, McClure et al. Now this is an interesting thing because in science and health fields, so in economics, authors are always listed in alphabetical order. I don't know if you've noticed that. In a lot of the fields, they're not. And it turns out that what happens when you're doing neuroeconomics is you first have to find a neuroscientist who has the equipment, right? And then you have to collaborate with them. And because they have the equipment, their name always goes first. So this paper is, from the standpoint of behavioral economics, this is actually a David Leibson paper, and you're going to see David Leibson on Tuesday again. So David Leibson is the important name buried in the et al. Here. Okay, so the lateral prefrontal cortex, their hypothesis was this, knowing all of these things about different parts of the brain, that the lateral prefrontal cortex and other cognitive areas of the brain will be activated basically whenever an intertemporal choice is being made, because there's cognitive deliberation involved in any time you're making an intertemporal choice in which you have even a few seconds to think about it, and that the limbic system, among other sort of non-deliberative parts of the brain, will be activated when and only when there's an immediate reward available, right? So now the beta self is triggered. Does that make sense to you? Okay, wait, let's see what happens next. Okay, Well, it's your class time, too. Okay, so whatever's troubling you, hang on to it. In 2 slides, raise your hand if it's still a question. Yeah? Okay, so how would we test this hypothesis? We can use functional magnetic resonance imaging, fMRI. And what it does is it essentially kind of makes a movie of what parts of your brain are quote-unquote activated. Now, there's all kinds of methodological debate in this field about what activated means and whether activation is really what we're seeing, but there's a decent amount of consensus that this methodology is valid in some ways. And you watch what the brain does when an individual is actually caught in the act of making an intertemporal choice, right there. And here's how it works. Okay, here's what's called an fMRI tank. Okay, the M in fMRI is magnet. That's that thing. This is an insanely powerful magnet. If you hold up a steel ball and let it go across the room from one of those things, it will go horizontally straight towards it and stick to it, and you'll have a hard time pulling it off. So what happens is this: there's a subject that goes sliding into the tank. Has anybody here been inside an MRI? Okay, so it's a similar kind of experience, right? There's all this knocking and clanking. It's very horrifying. Anyway, this is a little bit different because it's actually making sort of a series of snapshots that gives you a move, that captures activity moving over time. So there's a snapshot of the brain. That's just one moment in time. But the fMRI is actually going to allow you to sort of see this unfolding rapidly over time. What's happening here? Brain activity causes heightened blood flow, right? Anytime you use any cell in your body to do work, blood goes there to fuel it. And so then the blood shows up on fMRI because what fMRI is actually picking up is different degrees of it's picking up water, basically wetness. So then the snapshot tells us that there's activity in these different places. Fine. So here's the experiment. You install a computer screen inside the tank so that once you're slid in there, it's a very natural decision-making environment. You're on your back inside a tank. There's all kinds of noise and banging, and there are people in white coats outside who've taken away all of your metal objects. And then there's a screen. And the screen confronts you with these intertemporal choices. This is real stakes for money. It's also been done with real stakes for fruit juice. Because they actually had a little pipe in the mouth that would squirt fruit juice. Really true. Really true. Okay, so here are the kinds of choices that people, you've seen these before. This type of choice will be very familiar to you by now. The choices are of the following variety. So you have dollars x, so x dollars at some period of time t versus x prime, which is a larger amount at some delayed period t prime later than t. So for example, if x is, so this is you inside the tank, right? So if t is now, and you're being faced with the option of taking x now, and t prime is somewhere out in the future, and you've got x prime, which is bigger, right? So this is the classic $100 now, $105 in 2 weeks. And then the other kind of decision that you might be faced with is that t is out here somewhere. This is you in the tank. T is out here. T prime is out here. X prime. And this is 105 in a year, 100 in a year, 105 in a year in 2 weeks. Okay? So we're very familiar. This is exactly the same kind of thing that was being done in that 2-stage experiment that we looked at the last couple of periods. Okay? Sometimes t is now, sometimes it's in the future. And now this is a little bit tricky when you do this stuff because we don't actually know, in the same way that we don't know what the reference point is in any given context, we don't really know what now means, right? Sometimes we think now means anytime this week, and sometimes now really means now. In this case, now means you get paid as soon as the experiment is over. There's always this big methodological confusion about, well, when does that mean you're actually going to go and spend the money? But to a first order approximation, what we think we see is that people get a utility hit right when you give them money, and it empowers them to go and buy something right away. Fine. The reason they do this with fruit juice is to eliminate that problem, because the fruit juice, you get the utility now. Okay. All right, fine. Here's what they saw. The cognitive areas lit up, quote unquote, got blood supply whenever any choice was presented, right? So we can call these the delta areas, all right? Fine. It doesn't matter what these areas are. Like I said, I don't know enough about the brain to be able to comment on that. And the limbic areas, the beta areas, lit up whenever an immediate option was available. So exactly as they hypothesized, okay? So we'll call those the beta areas. These are the 2 cells inside your brain. Now, to take things a little further and cement this result a little bit more solidly, so here are 2 sets of decisions. Ones in which the person actually chose. Right, so these results, let me back up. These results have to do with what areas lit up as a function of what options were available, not what options were chosen. So if there was no immediate now option, the beta area of the brain didn't even light up at all. Okay, only the delta area lit up. When there was a now option, the beta area lit up, and then this additional set of results says what happened in situations where people chose the immediate option versus situations where they chose the delayed option. And lo and behold, what you see is that when they chose the early option, there was more beta activity than delta activity, and when they were willing to delay, there was more delta activity than beta activity. Okay. So one possible interpretation of this is that in situations where people's delta self, their sort of patient-wise, you might say rational self, was dominant, right? They were able to choose the later payout, and in situations where the beta self was dominant, they blew it and chose the earlier option. Okay. Now these gaps are all very short, so it's kind of hard to argue that it's in the long run a good idea to ever take the earlier, smaller option. So we can sort of say that choosing early is a mistake, and the mistake seems to be driven by this beta part of your brain. Okay. Now there are other ways you can interpret this graph, but that's sort of the most natural or obvious intuition about what's going on. Yeah. Oh, those are error bars. Those are the error bars. So this here is the 95% confidence interval around the point estimate. So one of the things you get out of this, right, is the fact that these error bars don't overlap means that you can be more than 95% sure that those 2 results are different. That the amount of delta activation is statistically significantly greater than the amount of beta activation when people chose the delayed option. Here there's overlap, so we don't get statistical significance, but these slopes I'm pretty sure are statistically significant. So for sure we can say there's really a difference in what's happening in your brain between these 2 different circumstances. Okay. Now another possibility, by the way, and I don't want to get into too much discussion about this, but another possibility is that people chose the early option when it was more tempting, right? When the sort of stakes were a little bit higher and it was more tempting, and the fact that it was tempting is what made the beta light up. We don't know. We don't know which way that causality goes. But this is pretty compelling evidence in support of this sort of psychological or behavioral economic idea that there are 2 decision makers. Okay, and then we can think in terms of those.